so Mr. Yasuda back here with another math video for you. Hopefully you enjoy it. If you enjoy it, don't forget to like and subscribe. You know how it is. But anyway, today we're going to talk about logarithmic inequalities. So you have to think about a couple things when you're solving a logarithmic inequality. It's kind of cerebral. So there's two things that you have to remember. The first is you have to remember how to find the domain of a logarithm, and we'll talk about that. And then the second thing is you have to recognize you're going to get a solution, but your answer to a logarithmic inequality is going to be where the solution and the domain of the logarithm intersect. So those are the two things that we need to remember as we start solving logarithmic inequalities. Okay, so I've got one right here. So we'll start with this guy. So you're going to solve it very similarly to the way that you've solved logarithms and logarithmic equations in the past. And so I'm going to encourage everyone to exponentiate both sides. Once the logarithm is alone, you're going to exponentiate both sides, and then you'll be able to get x free from inside the logarithm. Right? So I'd write 2 and then to the log base 2 of x minus 2. So that just becomes the exponent, the left side does, and then is less than or equal to 2 raised to the 4th power. Okay? So 2 and the log base 2 cancel out, leaves us with x minus 2 is less than or equal to 16. We're going to add 2 over. X is less than or equal to 18. So to the untrained eye, or to the math noob, the answer would be x is less than or equal to 18, which actually is kind of right, but it's not all right. So you have to understand logarithms have a domain that's restricted. You can't just plug anything in for x and think it's going to work out. So what you have to do is you have to think about what's the domain, and the way that we find the domain of a logarithm is we look on the inside of the logarithm and we say, okay, when is x minus 2 greater than 0? Because you can't actually take the logarithm of something negative or when it's 0. So this would be x is greater than 2. So the reality is that all x values in this problem, before it even starts, all the x values have to be greater than 2. You can never have an x value less than 2, because then it would make the inside of the logarithm negative, and therefore it would be undefined. And so when we're looking at this problem, if you want a visual, let me give you a visual. We have our solution, right? Our solution of x is less than or equal to 18. I'm going to put it on a number line. So here's 18, okay? And x is less than would be a closed circle, and it would go that way. Then if you think about x is greater than 2, I'd have 2 here. It's less than 18. And then I'd use an open circle, and it would be greater than, so it goes this way. So the answer is going to be where the two solution sets intersect. So the two solution sets, oh my word, what a tongue twister. But anyway, two solution sets would be from 2 to 18 is where the two sets overlap. And so this right here is going to be our answer. And so the answer is not x is less than or equal to 18. Our answer, right, is going to be where they intersect. So 2 with a parentheses, because it's got to be greater than 2, and then 18 with a bracket, because it can equal 18. Okay? And so that's going to be our answer. So really important, you have to know how to find the domain. Then not only do you have to know how to solve, but you have to think about where does my domain and where do my solution sets overlap. And if you need to draw a picture, I would draw a picture using a number line just so you can see where they overlap. That's called the intersection. Okay? All right, let's try another one. So we've got this guy. 3 times log base 10 of 4x plus 3 is less than 1. So we're going to divide by 3. And now we've got log of 4x plus 3 is less than 1/3. Okay? Then we're going to exponentiate both sides. So 10 log base 10 of 4x plus 3 is less than 10 to the 3rd power, which is the same as a cube root. So we'll have 4x plus 3 is less than, and I'm going to write it as the cube root of 10. All right? And so now we're going to get x alone. So if everybody's with me, I would get x is less than the cube root of 10 minus 3, and then all of that would be divided by 4. So I just kind of solve it that way first, then I'll go into my calculator and I will get my solution, or my decimal, my estimated solution. So I'm going to use my calculator real quick. So I just plugged that into my calculator, and I got x is less than negative 0.211 roughly. All right? And so once again, probably not my answer. And the reason being is we need to check our domain. So let's go back, and we need to figure out the domain of this logarithm. So the domain would be found by doing 4x plus 3 is greater than 0. We're going to solve that. We're going to get x is greater than negative 3/4. So the x values have to be greater than negative 3/4, but when we solve it, the x values are less than negative 0.21. And so if you're struggling with fractions and decimals, let me give you a visual. Here you go. So negative 3/4 is negative 0.75. So here's negative 0.211, and here's negative 0.75. It's less than it. And so now that you look at that, you're saying, okay, it has to be greater than negative 0.75. So open circle, greater than that way. But then the solution set we came up with is it has to be x is less than negative 0.211. So it's now going to go this way. Okay? And so where do they overlap? What's the intersection between these two sets? It would be, once again, this middle part. All right? And so now we have something where we would say our real answer to this whole problem is going to be negative 0.75 comma negative 0.211. Okay. The last one is just one I chose so that it has properties of logarithms built into it. So when it comes to solving logarithmic equations or inequalities, you don't want to have lots of logarithms in the problem. You would rather have one logarithm on both sides, and so you could have something to the effect of the natural log now, and we can multiply it together because of the product property. So x squared minus 5x plus 6 is less than the natural log of x plus 1. And so we can exponentiate both sides, right? Sometimes I like to just maybe, it's not cheating, you know what I mean? But you're like, okay, e, and I just write a really fat e like that so I don't have to rewrite the whole thing. And then I know I'm going to raise this side to the e as well. Kind of sketchy, but you know, you get gets the point across. So that means this is x squared minus 5x plus 6 is less than x plus 1. Now it becomes a quadratic inequality, and if you don't remember how to solve quadratic inequalities, I got a video for that, so don't be afraid. Feel free to jump on over to the polynomial inequality video that I've got here, and you can watch that and then come back and watch this. But really all you got to do is set it to 0, and so it would be x squared minus 6x plus 5 is less than 0, and then you need to factor x minus 5, x minus 1 less than 0. I'm going to use number line to test my intervals. So I've got 1, I've got 5, so I'm going to test 0, I'm going to test 2, and I'm going to test, 6, and I'm going to plug them in and see which makes it negative. So 0 goes in, that would give me positive 5, so that's no good. 2 goes in, that's going to give me negative 3 and 1, so that's going to work. And then 6 goes in, that's going to be positive, so that's not going to work. So for right now, I've got that x, right, is in between 1 and 5. That's currently what I have. But once again, we know that that's not our answer because we need to come back. And now take a look at this. You can't just look at one of the logarithms. You have to look at all of the logarithms. So now we're looking at this. The first logarithm, right, would give you a domain of x has to be greater than 2. The second logarithm would give you a domain of x has to be greater than 3. And the last logarithm would give you one where it had to be x is greater than negative 1. Now notice they're all in the same problem. So since they're all in the same problem, it's not like you can plug a different x value into each one of the three spots. It doesn't work like that. Like if I say x is 5, then you have to plug in 5 for all three x's. Or if we say x is 0, then you have to plug in 0 for all three x's. So you have to look at these and say, okay, out of those three, what works for all of them? And the one that works for all of them, right, would be x is greater than 3. Any number greater than 3, right, is going to make all those logarithms true. So our first scenario is this, is that our domain is x is greater than 3. X has to be greater than 3, otherwise one of those inequalities will not be true, okay? It'll be undefined. And so x has to be greater than 3. Now come back to our solution set, right? We're saying that x has to be greater than 1 and less than 5. Well, we can't be 1, right? We also can't be 2, we can't be 2.5, can't be 2.6, can't be 2.3. We also can't be 3. We need it to actually be greater than 3. And so hopefully you can start to see your intersection forming. And so our answer is going to be from 3 to 5. But that would be the intersection between the domain and our solution of 1 to 5. Okay? That would be where they overlap. Once again, if you need a visual, give yourself a visual and draw them on a number line and see where they overlap. Otherwise, you should be okay when checking both things. Please remember, go back to the very beginning of this whole video, right? Very beginning. Please remember, to solve logarithmic inequalities, you need two things. You got to know the domain, and then you have to know where does my solution and the domain intersect. If you keep those things straight, you should be fine. All right? If you enjoyed the video, don't forget to like and subscribe. It's been a pleasure talking to you about the wonderful world of mathematics. Peace out.